Hello class, today we are doing lesson 6.2 and 6.3, which are on writing and solving proportions. So what is a proportion? Really, it's an equation that states that two ratios are equal. So for example, if I cut a pizza up into 8 pieces and I ate 4 out of those 8 pieces, well, I know that that is also equal to how many halves of the pizza? Well, that's equal to 1 half. So that would be two ratios. This is one ratio, this is another ratio, and they are actually equal to each other. Okay? Oftentimes when we are dealing with proportions, we might have these ratios set up, but there's a variable in one of the spots. And so our objective with having a proportion is to be able to figure out and solve for that variable. Now, how to solve a proportion? You can use something called equivalent ratios, which we'll talk about. You can just use some algebra skills, or you can use cross products. I will show you all 3 options today so that you can use your best judgment and choose whichever method you like. I will tell you right now that I think cross products is a really great strategy that always works, but there are sometimes helpful usefuls for the other 2 as well. Okay, so let's actually get into it. Example 1, it says use equivalent ratios or algebra to solve the proportions. So for letters A, B, and C, so for this chunk right here, I'm going to show you using the equivalent ratios method, okay? And then I'll show you the algebra way for the next set. So taking a look at these, in letter A, I have 5 over 6 equals x over 18. Now, if you kind of have some good quick number sense, you might notice that 6 is, you can get 6 into 18 just by multiplying by something. So if I were to multiply 6, I'm going to rewrite this, 5 over 6. If I were to multiply 6 by 3, so if I multiply this by 3, I actually get 18 on the bottom. Okay? Well, if I multiply that 6 by 3, I also have to multiply the top number by 3. So 3 times 5 is 15. All right, and that is equal to my x over 18. So now, because both of the bottom numbers are 18, I know what x is. X is 15. So what we did was we changed this first ratio into an equivalent ratio so that the bottom numbers matched. Okay, that's the same scenario that we'll do with letter B and C as well. So taking a look at the next one, I know that 7, if I were to take 7 times 3, that is 21. So if I did 7 times 3, I also have to take the top number times 3, which is 6, and that's equal to x over 21. So what does x equal? X equals 6. And the next one, so here, my smaller number is on the right side. 12 is smaller. I know if I were to take 12 times 4, that equals 48. So if I do 12 times 4, that's 48. What is 6 times 4? That's 24. So that should equal my other ratio, which is x over 48. So what is x equal to? Well, both bottom numbers are 48, so x is equal to 24. Now, that works really great when you're able to kind of immediately see what number you need to multiply with, like going back to letter B here. I immediately knew that 7 times 3 was 21. Okay, now not always are you going to have a problem where it's that easy. So like taking a look at letter D, I don't know 8 times what is 12. I'm not quite sure. And you could times by a fraction or decimal to get 8 times something is 12, but it's not as user friendly. So what I'm going to show you with the next set, with D, E, and F, is we are going to use algebra to solve. Okay, so I'm going to rewrite this problem. X over 12 is equal to 2 over 8. Now, in lesson 5.6, we learned that if you have basically, if you have a fraction, you can multiply by the reciprocal of it in order to clear out that fraction. Or if we go way back to when we were solving equations, way back in pre-algebra, we often did the opposite. So I can take a look at this x over 12. This right here is the same as division. So what is the opposite of dividing by 12? Well, timesing by 12. So if I were to times both sides by 12, these two 12s cancel. And now all I have left on the left side is x. And then now I have to do this. 2 times 12 is 24 over 8. 24 divided by 8 is 3. So what does x equal? X equals 3. Okay, let's do another one just to get us some extra practice there. So I'm going to rewrite the problem. 3 over 10 is equal to x over 100. And now the whole goal here is we want to clear out the number that's underneath the variable, the x there. So how do I do the opposite of divide by 100? I multiply both sides by 100. Okay, so then those cancel. On the right side we just have x. And what I'm doing here is I'm taking 100 times 3, which is 300, and then I write that over 10. Well, 300 divided by 10 is 30. So x equals 30. Okay, letter F. I'm going to rewrite the problem. All right, now what is the opposite? Because here's my variable, the x. What is the opposite of divide by 9? Times by 9. So I do that to both sides. That cancels out those 9s there. So all that's left on the left side is x. 42 times 9 is 378. You can use a calculator for that. And then I just write over the 54. So I just bring that 54 down on the bottom. All right, and use a calculator. 378 divided by 54 is the number 7. So x equals 7. Okay, so that is another method to solve. And then here is the cross product property. That's what we're going to do for the next problem. And I will be honest with you, this is my favorite, okay? The other two, sometimes it's helpful if you have a certain problem in order to use equivalent ratios or algebra, but I will tell you that the cross product property, no matter what the problem is, it will always work. I think it's honestly kind of the quickest once you learn the method. So let's take a look at it. So cross product. The word cross means like this, like crisscross, right? The word product means multiply. So if I were to take a look at this picture right here, okay, what it's saying is that you're going to take B times C. So I wrote it down right here, B times C. That is going to equal the other two, A times D. A times D is here. So if I take B times C, that equals A times D. So here's an example. If I take 3 times 15, that's 45. That should equal 5 times 9. What is 5 times 9? Also 45. Okay, so that's showing us that the cross products are actually equal. So if, in example 2, let's try to figure out if these two ratios are actually equal, if they are a proportion. So what we need in order for this to be a proportion is we need 9 times 34, and I would just go ahead and use a calculator here. 9 times 34, and I'm going to write this product down below. 9 times 34 is 306. Okay, now let's do the other cross product. So I'm going to do 51 times 6. 51 times 6. And using a calculator, 51 times 6 is 306. So does 306 equal 306? Yes, it does. So is this a proportion? Yes, it is. All right, looking at letter B. If I take 12 times 50, whoops, my pen isn't working. Give me a second here.